Everybody, welcome to my presentation about the ET collision. So my name is Steven Zhang, and I'm from California of United States. So I'm currently go to Korean Lutheran High School. So who am I? So like I said, I'm a student from Korean Lutheran High School. So I'm currently living in Irvine, California. I'm a junior, 70 years old, and I like outdoors and driving. So what brought me to this project is that how did I got this idea and why developing a project like this? So basically, like I said in the previously slide, I'm a person that like to do outdoors. So one thing that I like about the most in outdoors is some beautiful scenery on the road or some the best views on top of a mountain or a destination. Now, I think a drone is the best way and the most convenient way to capture that view, since it can go to some places that you are unable to go during a vehicle or on foot. And I have personally crashed multiple drones while I was on a road trip. These drones are very expensive to prepare and very expensive to get all of your beautiful scenery back from a SIM card. So this lead me to think of a software that it can be controlled by coding and computer that it will automatically guide the drone away from the object. Unlike other avoidance product that's on the market, which will require an additional hardware or an additional software that you will need to control. So what is ET collision? It's a software. All you have to do is just take off the drone and it will do detect object and avoid it. So it does not need any requirement and add additional hardware for you to add or process during the trip. So for this project, I had select my favorite drone from my favorite drone company called Tello. So Tello is this drone that's on the screen right now. It's developed by DJI, which is the most advanced photo shooting drone on the market. The reason I choose Tello is because that it allows you and it supports you to do a lot of coding on different platforms. For example, it allows you to do coding on CS or Python. So my GUI, since our drone does not need any control, therefore the only control needed is entering the control from the drone to take off. So I like the bottom right, it says that you can see how the drone is processing. There's a little process bar that's what shows up to detect any object. So a little bit of a code demo. So on the left here is it will receive command and open video feed. What's good about our drone is that you can't just control it, but you can see it. And also you can send command for it to manually move away from the object if there is a system failure or error. And on the right here is the maneuver command, which is that was previously set due to special conditions to turn degrees and to move how far at a time. So therefore, it's a very modular. So you can set up this data in different type of situations. So first, we'll see our website to give a demo. So this is a website that I have created to talk all about the drone. For here, we'll see some videos to see how the drone does it work. So we'll enter the takeoff command and it will open up the video feed and the drone will automatically take off. And just like that. And as it gets close to the object, it will detect the object and automatically turn right. But however, in this situation, the right is not away. So therefore, it will automatically turn right again. So it will search back pattern, and then until the object is clear, it will continue to move straight. And this is the outside view of the drone. So basically, it detects the object and then it turned right. So it will continue proceed straight until it detects some object that will have a threat to its flight path. And then it will decision to make a different maneuver than going straight. So some challenge I have overcome when working on this project. So first, some of the drone, like the one you see in the background, requires a remote, which is that it will send you an alert when it's about to hit. However, it will not take over the drone's flight path or flight. It will not intercept the flight, which means that if you're off track or talking to your mate to show how the drone works, you could have easily just crashed the drone. So choosing a good platform that a drone does not need a remote to control or does not rely a remote to fly or take off is very hard. Moreover, you have to be able to support our platform, such as Python, which we use primarily for this project. And second, getting a good positive feed and detect the object is hard, since our drone runs on a 30 frame per second video feed. It was very hard for the drone to connect it to our computer or a laptop, since we'll use Bluetooth to connect the drone. So whether we'll get a weak feedback or we'll get a strong feedback, that will intercept the success of processing the picture that is sent back to us. Therefore, it will lower the successful chance of it detecting an object. So some of the future developing, which is the Tello only have a 10-minute flight time. We're hoping to come up with a new set of code or a 2.0 version to lower the data that was used to process through the drone. Therefore, it will give a less pressure on the battery, which will give it a longer flight time. And second, we want to support it with a stronger drone motor. So which means that we can carry more stuff, or even we can even deliver some fast food such as DoorDash or child bus to the person, which means that there will be no more traffic collision caused by the rush of a deliverer. And third, we were hoping to have an emergency landing, which means that the drone will automatically land straight down by itself. So this means that it will reduce the risk of having an error and hurt somebody due to the propellers are spinning fast. And last, we're hoping to upgrade our frames per second, a better feedback from 30 to 60, which means that we can detect more object in those frames and you'll have a much smoother feedback for the controller to see. So my contact information is that the website and my email. And that'll be it. Thank you.